Hello everyone, welcome to Digital Image Processing class. In this video, we will introduce how to measure distance between two extracted visual features representing two images. So far, we have completed tasks in the first step, including first, converting RGB image to 6-bit color-coded image. Second, building histogram counts based on 6-bit color-coded image. Third, normalizing histogram counts based on image size. Fourth, using extracted visual features to represent an image. Fifth, storing visual feature vectors in a matrix as an image database. Content-based image retrieval (CBIR) frameworks aim to find similar images. To achieve this goal, it is essential to compare the similarity between two images. As we represent an image as a visual feature vector, we must develop a measure to evaluate the similarity between two visual feature vectors representing two images. There are two commonly used approaches to describe the similarity between two objects. The first approach is called distance measure. The scale of a distance measure is typically from 0 to infinity, where 0 indicates identical and infinity indicates non-similar. The second approach is called similarity measure. The scale of a similarity measure is typically from 0% to 100%, where 0% indicates non-similar and 100% indicates identical. Distance is inversely proportional to similarity, which means that shorter the distance value indicates higher similarity. In this project, we adopt a widely and commonly used distance measure named Euclidean distance. Euclidean distance, also known as L2 norm, which is the straight line distance between 2 points in the space. Assume we have 2 points, P and Q, in a one-dimensional space. We can use a ruler to measure the distance between them. For example, as shown on the screen, P is at 3 and Q is at 8. The distance between P and Q is A minus 3, which equals to 5. We can further extend the straight line distance to two-dimensional space. Assume we have 2 points, P and Q, in a two-dimensional space as shown on the screen. We can use two rulers to measure the distances between them in terms of x direction and y direction. For example, in x direction, the distance A between P and Q is 7 minus 3, which equals to 4. In y direction, the distance B between P and Q is 3 minus 0, which equals to 3. We can obtain the straight line distance C between P and Q by using the Pythagoras theorem, as the equation shown on the screen. This measure can be further extended to three-dimensional or n-dimensional space, and thus we can summarize the Euclidean distance as the formula on the screen. In this project, we represent each image using normalized 6-bit color-coded histogram counts as a visual feature vector of length 64, which can be considered as a point in a 64-dimensional space. Therefore, we can use this formula to measure the distance between any two images as 2 points in 64-dimensional space. We can simply create a MATLAB function named getDistance to calculate the Euclidean distance between two visual feature vectors representing two images. This function takes two visual feature vectors as its input parameters, p and q, and returns the distance d between p and q. We implement the formula using matrix operation as shown in line 5. We perform matrix subtraction between q and p, which give us the distance between p and q in terms of each dimension. Then, to make the distance positive values, we square the distance for each dimension using element operation. Then we take the sum of all squared distance and take the square root to get the distance d. Once you have implemented the distance or similarity measure, we can establish the CBIR framework. This is a typical CBIR framework. The image on the left represents an query image, and the images on the right represent a collection of images stored in the database. These images are called target images. First, primitive visual features such as color, texture, shape, and spatial location are extracted from these images. In our project, we extracted the color feature, which is the normalized 6-bit color-coded histogram counts. Second, the distance is measured between the query image and each target image. Then the target images are ranked in increasing order of their distances to the query image. The ranked image list is returned to the users. Thank you for watching the video. Bye-bye.